All right, guys, here's the final video for volume and surface area that I'm going to provide for you. I did realize that after I signed off, that I forgot to show you what you currently see on the screen is our formulas that we're going to be using for the next assessment. So they're in your notes. You don't have to worry about reproducing them or anything like that. And I also noticed that on the last video, I forgot to go through example 5, but we're going to cover that, I think, in this video. And that's a hemisphere. A hemisphere, again, is just one half of a sphere. So when you're trying to find the volume and the surface area, all you have to do is take those values for the sphere and divide them by 2, okay? Because a hemisphere is half a sphere, all right? So apologies on that. But what we're going to do now is we're going to take what we've already learned regarding plugging in the formulas, and we're going to apply that now to combination problems where we have shapes that are composed of these solid figures. Like it could be a prism with a cone, or a sphere with a cylinder, or those kinds of ideas. And we're also going to find other values of these figures. For example, if I know the volume of a pyramid and the base area, can I find the height? We're going to work problems like that at this point now too. And that's what your final homework assignment's over on Canvas. It's about applying these formulas. Can you find other dimensions of these shapes if you're given the volumes and surface areas? And can you combine the shapes together to find the areas of composites of these figures and those kinds of things, combinations and stuff like that. So I have several examples to go through. I'm not going to go through all of them all the way. I'm going to leave some for you to finish, but I'll at least get you started on every single one of them here. So you can get going, and then you'll have plenty of practice to do on your assignment, okay? So there are the common formulas we're going to use. Again, you don't have to memorize these formulas. You're going to get them on your assessment. What you have to be able to do, though, is know where the values go in the formula correctly and how to use them correctly so you can get the correct answers, okay? Let's take a look at our first problem. So this is our first one that we have right here, okay? And you're given the volume, and again, it's a good idea here to mark the text. So let's do some marking, okay? So the volume is 24 yards, okay? And we know that the radius is 3 yards, so I'll mark that in blue because that's what we've been doing. So the radius of the cone is 3 yards, and we want to find the height, and we've been doing height in red, so we'll just keep that red. So determine the height of the cone. Okay, so there we go. We know the volume formula for a cone, so let's start with that. So we know that it's going to be V equals 1/3 pi r squared h, okay? And what we're going to do now is we're going to actually solve this formula for h, okay? We're going to plug in all the numbers we know, and then we're going to solve it for h, and then we'll put everything in the calculator and get an approximation for h. That's how we're going to solve it. So follow along with me on this first one so you know how it goes along here. We're going to start by plugging in all of our numbers, okay? The radius, of course, is 3 yards, so we're going to mark that blue so we know what that is. And h is going to stay the same, okay? So here's what we're going to do. We're going to plug in our r, so we have in our volume. We're going to start with our volume. So we're going to plug in 24 pi. Okay, so plug in the whole thing. So 24 pi, okay, equals 1/3 pi, okay, and then we're going to throw in our radius. So it's going to be 3 yards, so 3 squared, and then times h. And I just realized that I need to highlight the h in red, so my apologies on that. There we go. Okay, so that's the setup right now. It looks like it's a mess, but a lot of things are going to happen here in just a minute, okay? And don't worry about the pi's. The pi's are going to work themselves out. I'll prove it to you here in just a second, all right? So first of all, just work it like you would if it was a regular problem. We're going to square 3. And again, 3 squared is 9, so we're going to have 24 pi. Okay, so 24 pi equals 1/3 pi, okay, times 9 times h, okay? Now, the next thing I would probably do here is I'm going to go ahead and write the right side of this equation as my fraction, I'm going to divide everything by 3. So I'm going to take 9 times pi times h and divide it by 3. And you'll see something really cool happen with that. And then we'll be able to get this solved for h rather fast, okay? So let's rearrange the terms here a little bit. So we have 24 pi equals 9 times pi, keep the h in red so we know that's what we're solving for, times h, divided by 3, there's your 1/3, okay? And we can go ahead and divide the 9 into 3 here and get that worked out. So that's what I'm going to do. So I have 24 pi, and 9 divided by 3 is 3 pi, so it's 3 pi times h. In fact, this is not even going to require the use of the calculator at this point. If I want to get h by itself, ladies and gentlemen, all I have to do is divide both sides of my equation by 3 pi. And when I do that, those cancel on the right, these cancel on the left, the pi's go away. I'm left with 24 divided by 3. So in that regard, that's 8. So my height then is 8 yards. Okay? And that's how you can use these formulas to find the dimensions of missing components. So that's what we're going to have to also do in this section of our work, is use these formulas not to find the volume, but to find like heights and base areas and those kinds of things, okay? So I want you to look at problem number 2, and I'm going to let you pause. I want you to try to figure out problem number 2 on your own here, okay? And then I'll give you a hint or two to kind of get you going, and then I'm going to let you finish on your own. So hit the pause button for a minute and work on your own, and when you're ready, unpause, and I'll kind of give you a couple of hints on what to do. Okay, so we know that the volume is 12 cubic feet. Okay, so we mark that. The height is 4 feet. Okay, we're going to find the length of the base, and we know it's a square base. It says square up here. Okay, so we know that a square has equal sides. Let's go ahead and mark square base. There we go. And we need to find the length of the base. Okay, that's what we're trying to find. So if you remember our formula for the volume of a pyramid, okay, it was V equals 1/3 area of the base times the height. So we know the height is 4. Okay, so we'll put that in our formula. And we know that the area of the base, let's do a little scratch work over here, that the area of the base is length times width, which in this case is x times x. And if I remember that from my exponents unit, x times x is x squared. Remember, x to the first times x to the first, and you add them together, x squared. Okay, 1 plus 1 is 2. So here's what we're going to do. We're going to plug all this information into the formula. So I'm going to replace v with 12. Okay, and then I'm going to have my 1/3 here still. I'm going to change capital B to x squared. Okay, and my height is 4. All right. And then what we're going to do is, again, set it up as the fraction. We're going to make it divided by 3 on the right side. So I'm going to have 12 equals, keep the x squared in blue, so x squared, so we know what we're solving for, x squared times 4 divided by 3. Okay? And then what we're going to do is we're going to multiply each side by 3, get rid of the denominator here of the fraction. Okay? 12 times 3 is 36. So I have 36 equals, let's erase that, put it in black. So we have 36 equals x squared, well, times 4, which would be 4x squared. So 4 times x squared. I'm going to leave it there for you to finish solving it, because at this point you should know how to solve an equation like this, because now we've done it before in class, but especially with the last unit when we talked about the Pythagorean theorem. So you can go back to your notes there and see how to solve that. But you are well on your way now to solving this problem, figuring out the length of the base of the pyramid. All right. Now let's look at something even more interesting. I got another problem here. We're going to get it set up. I don't know if I'm going to show you the whole thing or not, but I'll at least help you out here with part A. I'm going to reduce it down a little bit so you can see it here in full view. This is a very interesting problem where you have a hourglass that is consisting of two pyramids. Okay? There's a pyramid on top of each other, and the sand is in one of them, and that's how it works out. Okay? And they're joined together to the apex, which is the point where they share in common. Okay? So let's mark the text here. See what we were given. The height of the pyramid is 6 inches. So we have that. And the area of the base of the pyramid are 15. So the area of the base is 15 square inches, which is nice. So that way we have capital B there. That's good to know. Okay, and that's also right here. So that's good. And it also said up here that I think it's also important to mark that the bases or the pyramids have the same dimensions. Okay. So that's also, I think, important to go there with. So all we have to do to get this volume is find the volume of one pyramid and double it. Okay, multiply it by 2. Okay, so I'm going to let you figure that part out on your own for a minute. You have the pause button here. I'm going to let you figure out that volume on your own, and then I'll come back to you in a minute and with the volume, and then we'll work part B of this problem. All right, I'm going to go ahead, okay, and find the volume of one pyramid. So it's going to be V equals 1/3 times 15 times 6. That's going to be 1/3 times 90, which means it's going to be 90 divided by 3. And that's going to be 30. And that's the volume for one pyramid. So if I want the volume of two pyramids, I'm going to get 30 times 2, which is 60 cubic inches. Okay? Now, let's look at part B. Grant is going to fill the hourglass with sand. The sand Grant wants to use this comes in a container shaped like a cube that is 2 inches on a side. How many packages of sand does Grant need to fill the hourglass 2/3 full? Okay, let's make a list of things we need to do in order to solve this part of the problem. Okay, first thing we need to do is figure out the volume of the container. Okay, and then let's put it up here. We need to figure out 2/3 of the hourglass's volume. Let's start with those two things and we'll worry about the third thing, okay? So for number 1, a cube has what volume formula? Right, length times width times height. This time all the dimensions are 2. So it's going to be 2 times 2 times 2. That is 8 cubic inches. Okay? Number 2, 2/3 of the volume of the hourglass. We go back up here. The hourglass's volume was 60. So 2/3 of 60. Okay? You can go over here in the calculator and do that real fast. You can do 60 times 2, get an answer. Divide that by 3. You get 40. So 2/3 of full would be 40 cubic inches. Now, if each container is 8 cubic inches and you want 40, all you have to do to figure out the volume is 40 divided by 8, which would be 5 containers. Oops, my box also messed up there a little bit. Let's try it one more time. There we go. Okay. So that's how you would solve part B. Now for the last one, I'm going to help you out with the first part, and then the second part I'm going to let you work out on your own. All right? So we have a snow cone right here. I'll go ahead and zoom it up here a little bit so we can see everything on here. Let's go ahead and mark the text here with what we have. It says both shapes have a radius of 4 inches. So the cylinder, not the cylinder, but the cone-shaped cup has a radius of 4 inches. Sorry, and the hemisphere of snow cone on top is also 4 inches. So let's do some marking here. So we have a hemisphere. Okay, we talked about that up there at the beginning of this video. We'll talk about how to do that. I'll show you how to find the area of a hemisphere here, or volume of hemisphere here in a minute. Okay. We know the height of the cup, 6 inches. Okay. And I'll go ahead and mark radius of 4 here also. Okay. Maybe we should change this to a different color so we don't get confused. So we'll change the hemisphere thing to green. There we go. Okay, kind of matches the colors there in the snow cone. That was unexpected. So let's start out and find the volume of the hemisphere. Okay, I'll show you how to do that. So remember, volume of a hemisphere is half the volume of a sphere. So it's going to be 1/2 times 4/3 times pi times the radius cubed. Okay? So if you multiply your fractions together, what you're going to get is 4/6 pi r cubed. All right? If you cube 4 times 4 times 4, you get 64. So we'll go ahead and put that number in. So we have 4/6 times 64 times pi. Okay? Which means we have 4, let's go ahead and write this as our fraction, 4 times 64 times pi over 6. And it doesn't matter if the numbers aren't reduced because we're putting them in the calculator, okay? So let's put them in here. So 4 times 64 times pi, whoops, I think I pushed the wrong button there. Let's try this again, times pi, there we go. And then we're going to divide that by 6, okay? Well, let's get our answer here so you can see the answer, and then we'll divide it by 6. Divide by 6. I get 134. And I'm running out of room, so I'm going to write it up here. 134.041. Oops, there it went again. Hold on just a minute. Let me bring it back down here. 04, whoops. Try it one more time here. I might be right there on that edge. There we go. And then over here to the side, I'll quickly find the volume of the cone. I'll let you guys do that while, in a minute, I'm going to pause. I'll let you find the volume of the cone with a height of 6 inches and a radius of 4 inches. Okay, so if you did this correctly, you should get V equals 1/3 times pi times, and I just realized I didn't colorize any of my numbers, but I think by now you probably got the hang of this. So be 4 squared times 6, so 1/3 pi times 16 times 6. Let's go ahead and multiply 16 and 6. Times pi divided by 3. So 16 times 6 times pi. Get an answer. Take that, divide by 3. And I get 100 100.531. Okay, so then to get the total volume, all you have to do is add up this number here. Let me highlight that instead of circle it. This number here and this number here, and add them together. Okay, so you can do that on the calculator. Just add these up. 100.531. Oops, let's clear this out. Start again. 100.531 plus 134.041. And your final volume is 234.572 cubic inches. Okay? Now, I'm going to let you finish B. If ice and flavoring costs 3 cents per cubic inch, how much would a snow cone with these dimensions cost? That one I'm going to let you figure out on your own. Okay? And those are your notes on volume and surface area. Please, again, let me know when you're ready to take the assessment. Again, you have to have the review assignment and the Knowledge Web completed and submitted before you're allowed to take the assessment. That's the bare minimum requirement. Note that you are still going to count, the other assignments are going to count for grade that I've assigned, but in order to get the assessment done, you have to do those things first, the Knowledge Web and the review assignment. All the assignments count, the Knowledge Web's counting this time, the fire-ups are counting this time, everything's counting, so make sure you get everything done. But the bare minimum is the review assignment and the Knowledge Web. And of course, if you have any questions, please let me know. Thanks, guys. I hope to see you soon.